Okay, this will be the fourth and likely final segment of the introduction to sampling distributions. And I'm just going to offer some summary comments here. As I was mentioning towards the end of the last segment, the point of this lecture, this YouTube lecture, has been to introduce the concept of sampling distributions. Now, again, as a quick review, each statistic that we've studied has its own sampling distribution, its own theoretical sampling distribution. And all the things that we walked through related to, imagine drawing repeated samples of fixed sizes and then calculating a mean and plotting those means, all that was simply to demonstrate, in theory, where the sampling distribution for the mean comes from. All right, the sampling distribution for the mean. And that's the only sampling distribution that we're talking about so far. That's the only sampling distribution that we're dealing with, the sampling distribution for the mean. And the sampling distribution for the mean, as luck would have it, or coincidence, as the case may be, the sampling distribution for the mean approximates the normal distribution. Okay, in all cases, let me make that clear. In all cases, the sampling distribution for the mean approximates the normal probability distribution, but the exact shape of the probability distribution depends on sample size, right? When we start with small samples, we have a flatter than normal curve, but approximately normal, vaguely approximately normal. When we increase the sample size to 10 to 20 to 30, it becomes more normal. And all of that is to demonstrate the inverse relationship between sample size and sampling error. Now, we've talked about error before, and we will continue to talk about error. But one of the main takeaways, actually there's several takeaways from this series of lectures. One of the main things I want you to take away from this series of lectures is the new statistic that we have introduced. And that is the standard error. S sub x bar, the standard error. That's a new statistic. That's a new statistic that you should know how to calculate. Standard deviation divided by the square root of n. That's the formula for the standard error. And what the standard error represents, it's a measure of sampling error that is dependent on sample size. I'm going to say that at least one time again. It's a measure of sampling error that is dependent on sample size. What do you do within the context of that formula? You divide by the square root of n. The larger the sample size, the smaller the sampling error. The smaller the sample size, the larger the sampling error. In fact, you could, if you wanted to, go back to all the exercises and worksheets and problem sets and exams and quizzes that we've done so far. You could go back to all of those and calculate the standard error for the sample simply by taking the standard deviation divided by the square root of n, the sample size. Now, we've been talking about the sampling distribution for the mean. And the sampling distribution for the mean can be found in your book, your SPATS book. It's not the Z probability distribution. We've been working with that before. That's the normal probability distribution. So it's not Z, but rather it's T. The T, lowercase t, distribution. And the T distribution looks like this. But you know what's down here? You know what's down here? Not units of standard deviation. That's what's at the bottom of the Z probability distribution. Z scores, units of standard deviation. You know what's at the bottom here? Guess. Guess what's at the bottom of the T probability distribution. Oops, I just gave it away. The T probability distribution. Guess what it is? T scores. Not Z scores, T scores. And you know what T scores are? You know what they are? Not units of standard deviation, but units of standard error. So you know how to calculate standard deviations, right? You've done it a dozen plus times, if not more. You also know, in theory, based on the information shared in these YouTube clips, you also know how to calculate units of standard error, which means you're in a pretty good spot, depending on how well these YouTube segments come off. You're in a pretty good spot to navigate the t probability distribution, which is where we're going next. All right, now, in the few minutes I have left before I hit the 10-minute mark on this video, I want to encourage you, to encourage you to rewatch these segments as necessary. Also, as I mentioned in class last week, there will be a practice exam dealing with pretty much everything that we've dealt with up through and including exam number 1 or post exam number 1. So please avail yourself of that. In addition, when we reconvene on Friday of next week, we will likely recap what I covered in these videos, and we will continue with that PowerPoint presentation, because what's coming next is a very specific statistical procedure that it's very important for you to understand, and that is the calculation of what's referred to as confidence intervals. All right, confidence intervals. What does that word confidence imply? Confidence. Confidence implies how sure you are of something, right? How positive you are that something's right, and also how sure you are that something's wrong, or the likelihood that it might be wrong. All right, so all of these YouTube segments today, this lecture that's approximating for Monday and Wednesday of next week, is all about thinking. I want you to think about sampling distributions. Sampling distributions are simply a special type of probability distribution. A sampling distribution, or in this case the sampling distribution for the mean, approximates the normal probability distribution depending on how big the sample size is. All right? The sampling distribution for the mean, approximates the normal probability distribution, but its exact shape depends on the sample size. So the sampling distribution for the mean is bell-shaped, approximately, symmetrical, we could cut it in half, and once we have reached 1, 2, 3 units outside of the middle, beyond the middle, 1, 2, 3, we've accounted for nearly all of it. Except the difference is, and this is a very important difference, those units, right? Remember, what's in the middle? 0, right? 1, 2, 3. We've accounted for almost all of it. Those units are not z-scores. Those units are not units of standard deviation. Those units, rather, are t-scores, units of standard error. Z represents units of standard deviation. T represents units of standard error. I'm going to say that again, and you're going to hear me say this about 10 gazillion more infinity times this semester. Z represents units of standard deviation. T represents units of standard error. Z, units of standard deviation. T, units of standard error. We use z-scores to navigate the z probability distribution, the normal probability distribution. We use t-scores to navigate the t probability distribution, the distribution that's based on standard error. So again, I'm going to say one last time and then I'll cut this off. Review the PowerPoint presentation up until the slide that says we can use confidence interval, or that's titled Building Confidence Intervals. That's where we'll probably pick up on Monday. Review these YouTube clips. Use the PowerPoint presentation, that's what it's there for, and refer to your supplementary handout. Also, of course, none of this is a substitute for reading SPATs, so make sure you've read up through chapter 6. All right, enjoy the practice exam on Blackboard when I get it up there, and I will see you on Friday. Have a great week.